after the first part of this video was uploaded, I got a question that about what I was making, and people obviously aren't familiar with what a bar puller is, but I'll try to explain it now. When you have a CNC lathe and you're making a lot of small parts and you don't want or can't use a bar feeder, this thing will do the same thing, or almost the same thing. This drawing here shows the bar puller from inside the spindle of the lathe, basically, and it shows a 20-meter bar, 20 millimeter maybe, and a 65 millimeter bar. So that's the capacity here. It will work from 20 to 65 millimeter diameter bars. And there's a gray part will be clamped on the turret, and this will be screwed to the gray part, obviously. And then after the lathe has completed one part, maybe it's 10 millimeters or 20 millimeters or 100, but not the complete or the maximum length between centers. You wouldn't use a bar puller for that. Anyway, when you have finished the first part and the lathe cuts off that, so it drops in the parts catcher or whatever, then you leave maybe 10 or 20 millimeters sticking out of the chuck or the collet, and you feed this tool down in the x-axis to the bar, and it grips onto the bar. Then you, by an M code, you open the chuck or the collet, and you move this tool with in the Z axis, the length of the part plus facing plus width of the cutoff tool. So if your part is 10 millimeters, you have a 3 millimeter cutoff tool and a 1 millimeter facing cut, you pull out 14 millimeters of bar. After you remove the 14 millimeters in the Z axis, you clamp the chuck again and then move away this tool in the X axis, and then you start on the next part. So that's the thing we're making here. I'm going to drill the holes in these fingers or small plates now, and since we want them equal, we'll drill them at the same time, so one is on top of the other. And we don't want to drill into a parallel, so I'll just barely stick them in there and then hammer it down, and then just leave it maybe 1 or 2 millimeters engaged, and then drill through both of them at the same time. But I'll try to set the 0 or in the middle there really precisely with the DRO and the edge finder, because I want the holes to be exactly in the center here. I'm going to spot the holes here. I usually don't bother with that unless it's critical, so I'll call this critical. The first hole is going to be at 6.5 millimeters. I'm using the DRO here now. Yeah, we have the first hole. good here now. I think I'm going to almost remove the parallel. Just a hot chip. There. And then 18.5. Pull out that parallel because it's in the way and just sneak it under the edge barely. Or maybe not. I'm being more careful here since we don't have any support underneath the part. There. We'll champ for this. I've set the quill stop, so it goes only down to there. And I guess we'll use lower edge here. And we'll see how it looks. And that looks about right. As you saw, when you hold it like this, it will rotate away from your fingers. I'll move it a little bit more that way. So that's nice. If you put this too close to the edge there and your fingers might get caught, but check just a little bit and then it's not dangerous at all. Okay, I've established two 0 points here, one for each of the parts on the DRO, so the 0 is in the middle, both in X and Y there and there. So we're going to drill a hole in the middle and the y-axis and 12 millimeters out from the center here. So one hole there and one there, one there and one there. We have the tap drill in here. And we're going to run. To adjust the zero so we have exactly 0. have any support. We don't want the holes to be crooked. All the way through. We're ready to tap M5. We'll use some cutting oil. I think we'll just start the tap here in the mill and then we'll reverse it out and finish it by hand. Or maybe we'll just run it all the way. We're going to finish the ends of the grippers now. There are very little left on them, so about half a millimeter. So we want to take off as little as possible on the first side. Like that. And then we'll measure. It's 25 hundredths of a millimeters left. Take 20 and then we'll measure. Yeah, it's 24.99. Which is close enough for this purpose. The chamfers on this side came out okay, and now I reset the DRO, so I'll just flip them over and we'll take off about 1/10 of a millimeter at a time until I'm at 0 in the y-axis. Since I still haven't received my new taps, I need to do the serrations, which I was planning to do at the end, but I guess I'll try doing them now instead. If we look at the drawing here, the pads need to be serrated that way, and the blue part, like this, need to be serrated, and this. Serrations are going that way. Yeah, that way on the underside there. And here I have a quick sketch of this one, like from this end. So we'll start with the first top half a millimeter from the edge, and then it will be evenly spaced. And we won't cut them to full depth because it will only be trouble with the interference in the bottom. It's going to be serrations like on Lathe jaws, 1.5 millimeter between each. Yeah, there's no way to see on the camera, I think, but the tops are flat here. And there is several ways of doing this. You can use an engine mill with a sharp corner and tilt the head of the mill and have the end mill go like so, but then you'll get 45 degrees or 90 degrees in the bottom, but that's okay, I suppose. Or you can use an end mill with a point on it, or yes, you could set it up in an angle block and use the end mill too. Nobody wants to tram the head of their bridge part, but if you got to do it, you got to do it. So I figured this would be the way. So we'll have a 90-degree wheeze and see if this works. The other way with the chamfering end mill did not work. They're not made to cut the wheeze. In a production environment, I'm sure this is done with something like a horizontal mill or something. And they have a cutter that goes that way with all the wheeze in it, so they cut it a lot at a time, very fast. When you tilt the head over like that, you run into all sorts of clearance problems. So, like that, if I had the end mill sticking out further, it would be okay. But as it is, collet chuck is lower than the end mill, so I have to do it at the edge of the vise here, which is okay, of course. I'll try to film this now. I'm gonna machine the serrations in the last piece, but now we run into the problem I talked about before. So I had to extend the end mill maybe almost 10 millimeters further out to get clearance for the collet chuck there. All the serrations are done now and everything works nicely. No errors in the indexing. So I'll just have to wait for the T-slot cutter, I think, if I don't figure out something else, some other small things I can do.